Hi, welcome to our third lecture. Uh, Last two classes we have seen how to. This is the review of the previous classes. We have seen what are the different ways a retaining wall can fail. We have seen this, and we have seen how to check the stability analysis of retaining wall for overturning and sliding. Okay, this is what we have discussed and we have done a problem also. Now in this lecture we will see, we told that there are three ways we can check retaining wall is stable or not. So in this class we will check the retaining wall is stable or not for the soil pressure at the base. Okay, let us see how do we do this. See the three figures here, because when a retaining wall is subjected to a load, there can be three cases will come. You see the first one, because these figures are the soil pressure diagrams at the bottom of the slab, base slab. Because this retaining wall, no, it is sitting on the soil, so the soil will have some pressure because of the load. So these diagrams, pressure diagrams, indicates the soil pressure. Three chances are there. Let us take the case by case. The first case is, you know, the diagram is like a trapezoid actually. So this soil pressure diagram at the bottom. So this indicates maximum pressure. This indicates negative. I mean the minimum pressure, sigma max and sigma maximum stress and the minimum stress. In this case, you can see that both maximum and minimum is positive. Okay. Now this case number two is the maximum is positive whereas the minimum is 0. Okay, and whereas the third case, you see the maximum is positive but the minimum is negative. So this case is dangerous actually. This and this we can, it's okay. When it is 0, it's fine. If the 0 stress is there, that is the best actually. That is an engineer, you look for that, but that cannot be possible every time. So you will have a value here, but this case it is negative. When it negative, what does it meaning is the minimum stress is negative? The meaning is you will end up with a situation like this. Well, just I will the case one and case two. I'm just showing in a picture representation again. The retaining wall, the case one is like maximum is positive, minimum is also positive. This is the soil stress distribution. Second case is maximum is positive and minimum is 0. Here this side there is no pressure. Okay, and the third case it is like this. You see it is a negative pressure generates here, negative stress diagram here. So what does it mean? Meaning is that there is no connection between the soil and this part of the retaining wall. There is a separation is there. You got the point. Means the retaining wall is not, there is not sitting, this location is not sitting exactly on the soil. Means there is no separation, there is no connection between this. It is just like a void like this. So this is very dangerous case, because if there is no connection between this soil and this retaining wall bottom, meaning is that all the load is transferred to this portion. So here we will have a heavy stress. So we want to avoid this situation. Okay, you understood the point, right? Now let us see how do we do this. So take a typical case of retaining wall. Okay, stem, base slab, and all everything. Okay, and this is the plan of the base slab bottom. So because I have taken only 1 meter width, this width 1 meter length actually, because retaining wall is going like anything, so I have taken only the 1 meter length, and the width is b, total b, and this line indicates the center line. So this will be b by 2 and this will be b by 2 total. Okay, so now see, this sigma w and sigma ph is the total vertical load and total horizontal load. Okay, and let us say this r is the resultant of these two. You know what is resultant? Resultant is nothing but this sigma w, this vertical load and horizontal load, what effect does it make on the retaining wall? If the same effect I can get it applying a single load, then that single load is called a resultant. So this is our resultant R. Okay, you see here, if I produce the resultant, it will reach here actually. Means it is not go passing through the center actually. It is away from the center. Meaning is that the center of the plant center is here, B by 2 here, this line. But this, if I produce it, it is passing through away. So meaning is there is an eccentricity is there. If the R is exactly passing through this center, then you will get a pressure diagram equal. Sigma max will be equal to sigma minimum. But here what happens, there is an eccentricity is there. It is passing more to this side actually. Okay, so our aim is how to find out this eccentricity. Okay, we'll be finding out how to find out eccentricity. So we will use the very basic of this one to find out, because eccentricity, you can, from this figure you can understand eccentricity E is equal to B. This is B by 2 minus X bar. If you know X bar, then you can find out eccentricity. See the figure, this is B by 2 minus X bar will give you the eccentricity. So our aim is B, we will be knowing it. Our aim is to find out X bar. So for finding out X bar, you will use some very basics of this one. So please have a look. So this is the same figure. I have just shown it like this. You can just we are going to take the moment of the forces sigma W and sigma pH to this point O, the bottom of the toe. Okay, here this point O, we are going to take the moment. So how do you take the moment? Moment is nothing but force into distance. So sigma W into this distance is x. Okay, this is coming here actually, not there. Sigma W into x, and so this sigma, we are taking the moment to this point O. So sigma W into x, force and distance is O. This will create a clockwise moment. Okay, and you see here sigma pH and y. This is the point O. So the distance between, perpendicular distance between sigma pH and O is y. So this will create an anti-clockwise moment. So we know that the algebraic sum of the moment should be equal to 0. So see sigma W into x is clockwise, so positive, minus sigma pH into y, it is anti-clockwise. Because of anti-clockwise I have taken it is negative. So sigma pH into y is equal to 0. Okay. Now the same way, you know, if any point you take, the algebraic sum should be 0. Algebraic sum of the moments of the forces to any point should be equal to 0. So let us take the case here, sigma W and sigma pH. Okay, so if you take this forces sigma W, sigma pH at this point to the point O, if I take moment, then sigma W into x bar, this is x bar. When I was taking here sigma W into x, okay, here now I am taking the loads, considering the loads at this point where this resultant is meeting here. Okay, so sigma W into x bar, okay, minus, this is a clockwise moment. Okay, and sigma pH into y, the only thing is that, you know, the sigma pH is passing through the point O itself where we want to take the moment. So your y will be 0. So at this point you will be having sigma W into x bar is equal to 0, only 1. So so initially we got it sigma W into x minus sigma pH into y is equal to 0, and now at this point we got sigma W into x bar is equal to 0. So both are 0. So equate this to this. So sigma W into x bar is equal to sigma W into x minus pH into y. Okay, next from this you can get x bar is equal to, solving this, you know, so x bar is equal to sigma W into x minus sigma pH into y divided by sigma W. What is sigma W into x? The last class we have seen sigma W into x is nothing but W1 into x1 plus W2 into x2 plus W3 into x3, W4 into x4, W5. What is that? This is a restoring moment. We have seen the first class, second class. And what is sigma pH into y? Meaning sigma pH into y1, pH1 into y1 plus sigma pH2 into y2. What is that? It is overturning moment. So this one you can write restoring moment, this one overturning moment. So x bar is nothing but restoring moment minus overturning moment divided by sigma W. Okay, so restoring moment, you know how to calculate. Overturning moment, you know how to calculate. Sigma W also you will get, you know how to calculate. So once you got X bar, then you see E is equal to B by 2 minus X bar will give you the eccentricity. Is that clear? Now let us take a case. This is a small portion of retaining wall. The length I have taken 1 meter, width is B. Okay. So generally you would have studied in columns and everything. The stress distribution, sigma max and sigma minimum. This sigma, the stress at the bottom of the load column or retaining wall, you can find out like this. This is you have studied in strength of materials, P by A plus M by Z, where P is the total load acting, area of the load, M is the moment, and Z is the modulus of the section. P by A plus M by Z. So let us substitute the value. Here the load is, total load is sigma W. So sigma W divided by the area is this one, B into 1 meter. Okay, area 1 meter plus or minus. What is moment? So sigma W, which is acting at a distance E from the center. So this will create a moment. Load in distance, sigma W into E, that is the moment. And Z is modulus of the section where the area of the load is acting. So it is BD square by 6 for a rectangular section. So B is 1 meter, D is B. 1 into B square by 6. Okay, so you will get sigma W by B. If you take a common factor, sigma W by B into 1 plus or minus 6E by B. In this, plus indicates maximum, that is sigma max, and minus indicates sigma minimum, that is sigma W by B into 1 plus 6E by B will be a sigma max, and sigma W by B into 1 minus 6E by B is a sigma minimum. So using this formula you can find out sigma max and sigma minimum. So you will have 3 cases like this. Now see the situation. What is our idea? Our idea is we should not have a situation like this. Sigma minimum should not be negative. Okay, that is our requirement. Sigma minimum should not be negative. Meaning is that should be equal to 0 or greater than 0. That is sigma WB by B into 1 minus 6E, because sigma minimum is this value. This is the previous figure. No, sigma minimum is this one. It should be greater than or equal to 0. Otherwise 1 minus 6E by B should be greater than or equal to 0. Or from this, so simplifying, you will get E should be less than or equal to B by 6. If E is less than or equal to B by 6, then you will never have a situation like this. Negative moment will not be having. Okay, so we will end up with 3 cases now. One is, first case is E less than B by 6. If E is less than B by 6, your stress diagram will be like this. Sigma minimum, sigma maximum will be positive. If E is equal to B by 6, then sigma minimum will be 0, sigma maximum will be positive. Okay. And if E greater than B by 6, you will end up situation like this. So you should not have a situation like this. Okay. Now just a point, once it is asked in the gate question, if E is greater than B by 6, your stress diagram will be like this. You will have a negative value, as shown here. E is greater than B by 6, you will have a negative value here. Negative, okay, it will be here. So in GT you would have studied, I am not going to the derivation part of that. If it is stress diagram coming like this negative part, then this portion from this where it is 0, that point to here the distance will be 3x bar, and this will be sigma maximum. Okay, so consider this is only this this point, this portion. Forget about this portion, it is negative. Only this triangular portion you take. Height is 3x bar and base is sigma max. So if I take the area of this one, that will be the total load or total force. We know that area of pressure diagram will be the total load or total force. Okay. So if I take area of this one, half into sigma max into 3x bar will be sigma W. The total load will be sigma W. Therefore sigma max is equal to 2 sigma W divided by 3x bar. So this is an important result, very important. If there is a E is greater than B by 6, your stress diagram will be like this. In that case, your maximum sigma maximum will be equal to 2 sigma W divided by 3x bar. So finally, the condition for retaining wall to be safe in soil pressure is your sigma max should not be more than SBC. Otherwise, your SBC will be always more than sigma max. That is what we need to check. Okay, so I'll just given a steps. Once you got a retaining wall with the loads and everything, then how do you check whether it is a stable on the basis of soil pressure? So first to find out overturning moment, you know that. Find out restoring moment, you know it, how to do it. Then find out x bar. X bar you can find out restoring moment minus overturning moment divided by sigma w. You know how to calculate all these things. And then once you got x bar, use the formula E is equal to v by 2 minus x bar. Find out eccentricity. Then check whether eccentricity is less than or equal to v by 6 or is greater than v by 6, because you will have in three cases like this. Okay, check it up, that one. Then find out sigma max, this using this formula. And once you got sigma max, you check whether your SPC is greater than sigma max or not. If SPC is greater than sigma max, then you are safe, because maximum stress coming on the soil will be less than the safe bearing capacity. So that is the ideal case. Then you are safe. So hope, if it is not safe, what to do? If it is not safe, what you can do is you increase the width of the base, so your eccentricity will be within the limit. Okay, that is what we can do. I think with this I will wind up this class. Any questions we will discuss. Thank you.